When we talk about computers, the CPU or central processing unit is often called the brain of the system. But what exactly makes one CPU different from another? In this video, we'll break down the four main specifications that define a CPU's performance and efficiency: clock speed, cache memory, operating voltage, and the front side bus or FSB. Understanding these specs will help you make sense of how CPUs work and why some are faster or more efficient than others. Let's start by exploring each of these crucial components in detail. First up is clock speed. Clock speed tells us how fast a CPU can execute instructions, and it's measured in hertz, usually in gigahertz for modern processors. Simply put, a higher clock speed means the CPU can process more instructions every second, leading to faster performance. However, it's not just about speed. Higher clock speeds also mean more heat and greater power consumption. So, while a fast CPU can be impressive, it also needs to be kept cool and powered efficiently. Let's see how this plays out in real-world computing. Next, let's talk about cache memory. Cache is a small but super fast type of memory that sits inside or very close to the CPU. Its job is to store frequently used data and instructions so the CPU doesn't have to fetch them from the much slower main memory every time. Cache memory is divided into levels: L1, L2, and L3. L1 is the smallest but fastest, while L3 is larger but a bit slower. This hierarchy helps the CPU access important information quickly, boosting overall performance and efficiency. Dive a bit deeper, let's look at the different levels of cache memory. L1 cache is the fastest and closest to the CPU core, but it's also the smallest in size. L2 cache is a bit larger and slightly slower, while L3 cache is the largest and slowest among the three. This tiered structure allows the CPU to access the most critical data at lightning speed, while still having room for more data in the slower, larger caches. The combination of these levels ensures a balance between speed and storage capacity. Now let's move on to operating voltage. This specification refers to the amount of electrical power the CPU needs to function. Lower operating voltage is generally better because it reduces power consumption and heat generation, making the CPU more energy efficient. However, if the voltage drops too low, the CPU can become unstable or even fail to perform properly. Manufacturers carefully balance voltage to ensure both efficiency and reliability, especially in laptops and mobile devices where battery life is crucial. Frontside bus or FSB is another important CPU specification. Think of the FSB as the main communication highway between the CPU and the rest of the computer, especially the main memory RAM. The speed of the FSB determines how quickly data can travel between the CPU and memory. A faster FSB means less waiting time for data transfers, which translates to better overall system performance. This is especially important for tasks that require a lot of data movement, like gaming or video editing. Each of these specifications, clock speed, cache memory, operating voltage, and FSB, plays a unique role in determining how a CPU performs, but it's their combination that really matters. For example, a CPU with a high clock speed but slow FSB might not perform as well as one with balanced specs. Similarly, efficient cache memory can make up for slightly lower clock speeds. The right mix ensures that the CPU runs fast, stays cool, and uses energy wisely, providing the best experience for users. Selecting a CPU, it's important to consider all these specifications together. Depending on your needs, whether it's gaming, video editing, or everyday tasks, you might prioritize one spec over another. For instance, gamers often look for high clock speeds and fast FSB, while those focused on energy efficiency might prefer CPUs with lower operating voltage. Understanding these specs helps you make informed decisions and get the best value for your investment. Wrap up the main specifications: clock speed, cache memory, operating voltage, and FSB are the building blocks of CPU performance and efficiency. By understanding how each one works and how they interact, you can better appreciate what makes a CPU powerful or efficient. Whether you're building a new PC or just curious about technology, knowing these basics will help you navigate the world of processors with confidence. Thanks for watching and stay tuned for more tech insight.